I have a background as a software engineer for many, many years. So I come with that perspective into data engineering and the analytics world. And the other thing about me is I'm really digging the everything tie-dye trend. So, all right. So let's talk about first how we deliver data and delivering data. Data engineering at Warby Parker, what the team that I'm on does is we build data solutions to cultivate a data-driven decision-making culture across all of Warby Parker. And how we do that, I view it as we provide an internal service. We are delivering analytical data to those who need it and when they need it. And we do that, as a team. It's a team effort. It's a really big challenge, and we do that with our engineering manager, our product manager, 2 data platform engineers, of which I'm one, and 4 business intelligence engineers. That those folks are doing the DBT at Warby Parker. So we're a pretty sizable team, and I'm on a great team. I gotta say, I like all my team members. They're all quite excellent. And just some stats there. We run about 200 batch jobs on different cadences, monthly, daily, hourly. We have about 300 DBT models in our main DBT project. And just a little extra, we have a GCP data flow pipeline. So we're dabbling a bit this year in more real-time and streaming data. So let's talk about the stack. I love talking about stacks, data stacks. Here we go. So on the left here, we have the data that we're working with. We have internal data. We have a big Postgres database and a product information system internal to Warby. And then we have, like a lot of you probably, a lot of vendors that we work with, customer vendors, surveying, marketing, and they have a lot of our data as well in their APIs. So we bring that data in. We actually use primarily Python to do extract and load into BigQuery as raw data. And then, of course, DBT, there you go, as our transform into our what we call our gold data models. So we're using that classic, or well, the new contemporary ELT pattern in order to get data into its modeled form. We run all of this in, well, cron recently, and we're just started dabbling in Airflow. Very excited to be making that transition. And we use Looker to query that gold data. And we have many hundreds of users at Warby who are querying it. And another recent addition is that we started extracting and loading that gold data itself into other tools. So we just added a budgeting and planning tool at Warby, and we're using that data to power it. That's our stack. It's great. And I would end my talk there, but delivering data is only one part. You got to do it on time and every day. So there's issues. There's always issues we got to work with. And we have a Slack channel where we're always fielding different questions. There's an error when I access the data. I need data in another system. The data looks wrong. But the one issue that we're going to be talking about today is the data is late or the data is missing. And that to me is the one of the biggest challenges, and that's part of delivering data on time and every day. So I'm gonna put this out to you all. Why does this matter? Why does it matter that data is on time? The challenge of late and missing. So why would we want to, as data engineers, deal with this problem? So I'm going to look into chat for a sec. Let's see if I can click over. Why does it matter that data is on time? Okay, wrong data. We might make wrong decisions if data is missing. The value of data has a half-life, says Ken. Greg says to have trust. That's good. All right, well, I asked some of my colleagues at Warby, why is it important that the data is on time? Max, our director of data, he says that late data is trying to cross the road with your eyes closed when you looked at it a minute ago. You might get hit by something. And also, he had a pun about eyes in there. I like that as a Warby and Parker employee. Brittany, our data eng product manager, she just knows everything about all the data needs across the business. She knows that it's important for data to be available first thing for operations of the business and for people to make decisions. People could waste their day if data isn't available on time. Like, we might be wasting people's time. Connor, who works in our consumer insights and does a lot of surveying of our customers, he wants data on time to catch opportunities to ensure that our customers go through a best-in-class experience. One thing that's interesting about him is he doesn't need real-time data, he told me. He doesn't need it. He just needs like yesterday's data today. So his latency is a bit tolerable. However, Brian on our performance marketing team, he says that within minutes, he looks at performance of ads in order to figure out if we should spend more or less on particular ad platforms. So he needs data on time within minutes. So let's go through an example here of a project that we've done at Warby as a company. Well, it's COVID times, but as a company that has over 100 retail stores now, we're very concerned about like how many people are actually coming into our stores. So the retail development team wants to know the foot traffic. It turns out that more people in the stores, you get more purchases, you get more orders, and the company is doing better. And they look at that from the perspective of over the long term. So they want to see for a particular store over time, over many, many months, how many people are coming in the store. But then also in the short term, the store leaders, they want to know how many people are coming in today. They want to know how many people are coming today so that they can report any issues or maybe find out if there's an issue with the store. Or so there's two kind of levels of on timeness that this data needs. And we can quantify that here just by putting it in a table here. So the requirements for the store foot traffic data is within an hour. Oh, and by the way we do this is with the vendor who sells a sensor that we install at the entrance of the doors, so that we can estimate how many people are coming in and out. And yeah, so the frequency we need this data set is an hour. So that's a project. It's come to us, and as a data engineering team, now we have to make this data available to them and make sure they can use it in the way they need. So of course, we think about the regular tools in our tool bag: Python, dbt, BigQuery, Looker. But another thing that my team and I are starting to do is to define a service level objective. So on top of all those things and tests and documentation that we produce, we also define a service level objective. And that is what our team commits to providing to our customers. And it has two parts: an objective and a target percentage. And the service level objective for this particular project is that store foot traffic data must not be more than 1 hour late. So I'm just like rehashing the requirement here. I'm saying that we will provide you store foot traffic data and it must not be more than 1 hour late. And talking with the stakeholders, we realized that this is actually very important data for them. Like, if they don't have it, they can't make the decisions they need to do. So we're going to really make a high percentage of how much of the time we're going to have this objective met, how much of this time we're going to have the objective met. So 99% of the time, we are going to make this data available not more than 1 hour late. But that also gives us a budget. It means that for 7 hours and 18 minutes of a month, we can have it late because we know there's going to be issues. We know that our flow is going to mess up, or BigQuery might not be available, or oh no, okay, I'll blame it on myself. We made a bug. Yeah, we made a bug. We know that's going to happen sometimes. So we commit to a level of service that's quite high, but not out of the realm of possibility. So great, we're making this statement, we're making this grand statement, and let's talk about the service level indicator, the way that we can hold ourselves accountable to the service objective. So we've defined this service level indicator at Warby Parker, which you may be very familiar with. Stale data. We say that data is stale when the timestamp of now minus the maximum timestamp of the table that we're producing is greater than some threshold. And so we're going to use this indicator type in order to hold us accountable to our objective. So for this particular project, our service level indicator will be stale data 1 hour. And it's going to be measured on this table that we're producing, retail in the data set retail, and the table foot traffic and the column measured at. So it's very specifically, we are not meeting our objective when now minus the max of retail foot traffic measured at is greater than 1 hour. And that's really powerful because then we know at a given moment whether we're meeting our objective, and we can know if we are going to hit our 99% target percentage. One note about the SLI and where to measure it. We have this whole transformation process getting that retail traffic from our vendor into raw data inside of our BigQuery before we transform it into the gold data and where the looker queries measure. Well, the service level we should measure is right where the users are going to look at it. So we want to say that the gold data is available within that 1 hour period. And that gives us a best understanding that we are actually providing that service level. So going on to next example here at Warby, another one we do, and you might do as well, is the NPS survey. So you've purchased a pair of glasses and you get this NPS survey at the very end. This data, as I mentioned in a previous slide, is helpful for our consumer insights team to know whether the customer enjoyed their experience purchasing their glasses. And we strive to have a very high NPS. We want people to promote Warby Parker, the Net Promoter Score. So this data, as I mentioned, is required the next morning. So Connor on the consumer insights team only needs this data next morning. And so we can craft a service level objective here to say that yesterday's customer survey data must be available by 9 a.m. Eastern. However, we've talked with Connor a little bit, and we've ascertained that it's okay. It's okay if it's like in the afternoon, but we're going to strive to make it for him when he rolls out of bed and turns on his laptop and available then. So we can dial back the target percentage, and therefore it's not as high a priority of an issue if we don't quite have the data on the time that we've promised him. So this is a slightly different service level indicator that we're using here. So whereas before we talked about stale data from the time now to the maximum timestamp, we're actually saying that if it's 9 a.m., if it's 9:01 a.m. and Connor doesn't have data from yesterday in the table, then we violated our objective. So that we've created this other indicator type called data overdue, which is like very similar but subtly different to the stale data indicator. And here is precisely that definition of data overdue. And so for the service level objective for Connor on the consumer insights team, we are using the data overdue on a table column, survey.nps.recorded at, and we're ensuring that this data is there by the deadline. So all this is making sense, but what I'm trying to show is that we have a few different reporting examples at Warby, and that we've developed a couple of different service level indicators to support that. Other things to talk about, like we're talking about measuring the data and the maximum timestamp that are in the tables. Job failures are another thing that we keep track of and are like leading indicators of missing data or late data. And so we keep track of that and keep tabs on the uptime of the jobs. And so say if the job fails there and the DBT has a bug, then the gold data is no longer available to the end users. And then data might start be missing later on. But a job failure is going to happen before the data is stale or the data is overdue. So we want to be alerted of those situations. And so that's another service level indicator we keep tabs on. So just a note there, actually, I'm going to take a pause, which is probably a good opportunity to ask you. There's another this issue here, the data looks wrong. Why is this issue particularly bad? Oh, that's a good one. Sometimes legal requirements binds you to deliver data on time. Mark says you don't want a skeptical data consumer. Loss of trust. Yeah. Yeah, I agree. Like, the data is missing and the data is wrong. Those are, to me, really bad issues as a data engineer to have. But I would say that the data looks wrong is potentially worse than the data is missing, because at least when the data is missing, the person can't even make an action on it. When the data is wrong, they might make a wrong action and might make a wrong decision. And maybe I would really encourage you to watch Klaus's previous DBT office hours on this. He talks about using a blue-green deployment step to check the data at the end of DBT transformation using tests. And if it doesn't pass the test, then it doesn't even hit the gold data model. And when it doesn't hit the gold data model, then the data is missing. And I think that's a better condition than having wrong data out there. So yeah, go check that one out. Another one we keep track of are long running jobs. So sometimes some of our jobs just get longer and longer and longer. And they might make us not hit our service level objective of getting Connor's data at 9 a.m. So that's also something we keep track of. And that's another indicator type. It's very similar to the data overdue, but we just use the job timestamp instead of the table timestamp. All right, going to the nuts and bolts a little bit of how we do it at Warby. We use Datadog. I'm a big fan of Datadog. And every 15 minutes, what we do is we compute all of our configured error conditions. So I talked about the retail traffic one. I talked about the NPS survey one. We actually have a Python process that will compute the error conditions every 15 minutes and then publish those results to Datadog as metrics. Their product called Datadog Metrics, which another similar product is StatsD. Then we use a Datadog monitor to alert us if any of those error conditions are true, and that we alert on Slack and then sometimes on PagerDuty. And then furthermore, I really like this because Datadog offers an SLO product on the monitor to tell us how long that the monitor has been in the error condition. So we can compute the SLOs for us and keep track of it for us. Yes, so as I mentioned, Datadog alerts us on Slack when the error conditions are met. And then key error conditions will page the on-call engineer on our team. So that 99% one, right? We only have 7 hours per month to be down. And we want to be alerted immediately, even if it's a little after the business hours, to tell us if there's an issue. And so we have an on-call rotation on our team between 8 a.m. and 9 p.m. 7 days a week, and our on-call engineer will be paged if the SLO is violated. And then finally, if our data is not on time, we write to our stakeholders when we're not meeting the objective we've promised. And we use email and Slack right now. We're investigating like ways to use other tools to indicate when service is not being met. However, our first pass is to use just written communication and to hold that trust. So coming to the end here, Warby Parker, we've got a nice system, a nice data stack. We have a way to keep track of our service level objectives. I mean, it's not entirely true. We have this as our framework, but it's quite new to us as well. So we are moving towards it and building and getting to where I presented. The advantages of this, I think, are we know what our guarantees are. So we can keep track of our list of what we're promising to our stakeholders. We also know what promises we're not meeting. So if we are not hitting that 99% of the time for our retail development team, then we know we need to spend some time there to get that working for them. It helps us prioritize our work. As an engineer, sometimes I struggle to point out issues in our system and our stack. However, when we're making commitments to the people who are using our data, and we are not able to meet those commitments for one reason or another, we are able to like identify areas of deficiencies in our stack and then be able to come back and work on those and make them better. So I found those conversations to be a lot easier when we have such commitments. And finally, and last but not least, it really helps us understand the difficulty of a project. So for example, if we have a 99% uptime on our SLO, that's considerably harder than a 95%. It means that we may have like more work in order, more tests to write, more. It just might be a more challenging project. Also, knowing the frequency, right? So, for example, in that retail store data, if we have to deliver it within an hour 99% of the time, that's a much harder project than I would argue within Connor's project, where we just need it the next day 95% of the time. So it really helps to like estimate how much effort we have to put into building the reporting. So maybe some tips to finish up here if you want to get started with this approach. Here's what I recommend. I recommend that you start writing simple and clear objectives at the start of the project. I also recommend that you start making agreements and setting those expectations with the stakeholders, the people using it. Like you can write it for yourself, but I think it's really powerful when you write it and you share that with who you're writing it for, and to agree on that or disagree on that. I think it really sets the partnership up for success. I talked about how we use Datadog, but that's not the focus of this talk. I really think this is something, a tool and a mindset you can use without having fancy tracking. I think, I have used Looker and I've used spreadsheets and I've used other means to keep track of when data is available and whether jobs have completed. And I've used that over time and just seen what the trends are and whether we're meeting. You can compute the percentage using spreadsheet formulas. I would consider starting with that approach to begin before going to any sort of systematized approach. And then revisit, after you start doing that, revisit those metrics, and that'll help you see where you need to spend your attention, which data pipelines need attention. Here are some more resources. I think I'll find a way to share this. In particular, I really like, GitLab is always a fun wiki to go around and see what they're doing because they're so radically open. They actually just keep track, have a spreadsheet, a table on their wiki with the integrations they're building and when they guarantee the data is available by. That's just a really simple and powerful way to express what your service that you're providing is. I love the Google SRE's handbook of service level objectives. It's focused more on, traditional software engineering like e-commerce or API uptimes. However, I think a lot of those concepts are translatable to our data engineering realm. And I'll just point out two vendors that I've seen recently who've been thinking a lot about data quality and observability. Monte Carlo, I've been loving the posts coming out of them. And Databand also has a product focused on that. I also saw today in Locally Optimistic, I think Great Expectations are also thinking a lot about data quality and delivering data on time. So if you're even interested in getting some help delivering data on time, consider these folks. I've never used them myself, though. All right, and finally, got to put it out there. Warby Parker, we're hiring. We got a senior data engineer position on the BI team available, and we're looking for someone really experienced in data modeling. I'm available as a mentor. I love helping people with data engineering issues, data issues, software issues, and I'm particularly interested in supporting the underrepresented members of our community, BIPOC women, LGBTQ+. So please contact me, and you can find me on Locally Optimistic Slack or DBT Slack.